Organic chemistry has been a big fear for most of the
Many
high school
often find it
students.
difficult
But
to
honestly,
implement
it's not
organic chemistry.
anything to be scared of.
Here,
Here, I'll
I'll be
try to
trying
explain
to
a few
explain
concepts
you
of organic
this
chemistry to
topic
you in a
in a
very
very
simplified
simple
manner.
manner.
To begin with, study of carbon and its compounds is called organic chemistry. Now, a big question comes into everybody's mind that why only carbon and its compounds are studied as a separate branch of chemistry while a total of 117 elements are known. The answer is very simple. Out of these 117 elements, carbon is the only one that forms such large number of compounds, and that too which are of immense importance industrially or otherwise. Now here follows the next question. Why carbon is forming such large number of compounds? Now, there are various reasons for this explanation. The answer is very simple, that out of all of these 117 elements, carbon is the only one which forms such large number of compounds, and that too which are of immense importance industrially as well as otherwise. Now this is followed by another question, why carbon forms such large number of compounds? There are various reasons behind it. The first being its tetravalent. Atomic number of carbon is 6, its configuration is 2,4. Carbon needs 4 more electrons to satisfy its valences. So, in order to do so, it combines with the atoms of other elements and hence results in formation of such large number of compounds. Second reason is the property of catenation which is exhibited by carbon. It is the property of self-combination of a carbon atom with other carbon atoms forming long straight chains, branch chains or ring compounds. The property of isomerism exhibited by carbon is yet another reason which results into the formation of such large number of compounds. Next comes how does carbon exists in nature. Carbon basically exists in two forms, free form and combined form. In free form, it exists in the form of three allotropes, namely diamond, graphite and Buckminster fluorine. All of these allotropes are made up of pure carbon only. The same can be experimentally proved by taking a sample of any one of these and burning it, which will result in the formation of carbon dioxide only. Now all these three allotropes are made up of only pure carbon, but yet their properties are entirely different from each other. This is because the arrangement of carbon atoms in three of these is totally different. In combined form, carbon exists as hydrocarbons if it combines with hydrogen atoms in the form of haloalkanes. If other than hydrogen, it is combining with halogens like chlorine, bromine or iodine. In the form of alcohols, acids, ketones or aldehydes, depending upon which functional group is attached. We'll be discussing all these combined forms in detail one by one. To begin with, let's talk about hydrocarbons. As mentioned earlier, hydrocarbons are the compounds which are made up of only carbon and hydrogen. Now, the number of hydrocarbons is large, so it is difficult for anybody to remember the names, structures or the properties of the various hydrocarbons. So in order to simplify these, various rules have been made. I would like to explain those rules one by one. First of all, the rule is to find the prefix which will be attached. That depends upon the number of carbon atoms present in a given hydrocarbon. As mentioned in the table, we have prefixes for carbon atoms numbering from 1 to 10. Like if any hydrocarbon contains one carbon atom, we'll be using meth. For 2 carbon atoms, we'll be using eth. And similarly, prop for 3 carbon atoms, but for 4, pent for 5, hex for 6, hept for 7, followed by oct, non and dec for 8, 9 and 10 carbon atoms. Once we have counted the number of carbon atoms and given a suitable prefix, according to the second rule, we'll look for the bonds present between the various carbon atoms. Now the point here to be noted is there is always single bond between any carbon and hydrogen atom. While using the rule 2, we just have to look for the bond which is present between any two carbon atoms. If all the bonds between various carbon atoms are single, we'll be using ane as the suffix. If there is any bond which is double, we'll be using the suffix "ene." And if there is a triple bond between any two carbon atom in the given hydrocarbon, we'll be using ine. Hydrocarbons are broadly classified into two types: saturated and unsaturated hydrocarbons. Saturated hydrocarbons are those which contain only single bonds, and under this category comes the alkanes only. While in case of unsaturated hydrocarbons, multiple bonds are present. It may be a double or a triple bond. As mentioned before, the unsaturated hydrocarbons with double bond are called alkenes, and the ones containing triple bond are called alkynes. Now here we'll be learning how to name the various alkanes. Rules already have been explained. Now we'll be actually implementing them. Look at the first structure. This structure contains only one carbon atom. Since every carbon atom has 4 valence electrons, it needs 4 more valences to satisfy itself. So this carbon is attaching itself to 4 other hydrogen atoms in order to complete its octet. So in this structure there is single carbon, so we'll be using the prefix meth. And since there are only single bonds present, we are using the suffix ane, and combining together the name becomes methane. For the second hydrocarbon discussed here, there are 2 carbon atoms, so we're using the prefix eth, and since there is a single bond between the 2 carbon atoms, we're using ane, which gives the name ethane. For the hydrocarbon with 3 carbon atoms, for the third hydrocarbon with 3 carbon atoms, prop is used as the prefix, and because it contains all single bond between the various carbon atoms, we're using ane as the suffix, hence the name becomes propane. Similarly, for the fourth carbon atom, we're using but and ane, that makes it butane.